All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to start by removing a 4, because that's the greatest common factor, and you're going to have x squared plus 6x plus 9 left. And so then the x squared plus 6x plus 9 will factor as x plus 3 times x plus 3, which you'll write as 4 times x plus 3 squared. For the math knowledge question, we want to start by distributing this negative. So we're going to have 7x minus x plus 3 equals 6. You have to make sure you distribute it to both of those two terms. So 7x minus x is 6x plus 3 equals 6. So subtract 3 and you get that 6x equals 3. And if you divide by 6, 3 over 6 is 1 over 2. So our answer is C, 1/2. Okay, so we are looking at lesson 74 today. We're looking at the graphs of secant and cosecant, and then we're going to look at the graphs of tangent and cotangent. So we've already looked at the graphs of sine and cosine. These are our other trig functions that we're going to look at the graphs of. So hopefully you'll understand these 4 graphs once we finish. So we have to write the equations of these trig functions, and they show us the graph of it, and we have to figure out the equation. I'm going to tell you this: one of these is secant and one of these is cosecant. And the way that you figure that out, everywhere that we have a hump, we're going to put a dot at the low point and the max. So everywhere you have that little U, you're going to put a little dot at what would be the vertex for your parabola. They're not actually parabolas, but you're going to put a dot there. And then you're going to go through the x-axis everywhere that you have an asymptote. And so what you're going to do is connect your dots by making a little curve. And there is an asymptote on the y-axis. You just don't see it because it gets covered up by the y-axis. Okay? So if you look at what I drew, that blue curve, is that a sine or a cosine curve? It is a sine. Okay? And so this is going to be a y equals, and we're going to look at Calc. The center line on this one is 0, so we don't need to put a number. We just have a 0. The amplitude here, we go up 1, so we have a 1, which on our amplitude, we don't have to write that 1. And then it's sine. So what is the reciprocal of sine? Cosecant of theta. Then we are going through the origin, so we don't have an angle change. And our period, going from here over to here, is 360, so we don't have a period change. And so this graph is y equals cosecant of theta. Now, I'm going to erase some of my lovely drawings here. The reciprocal of 1 here is 1, and so that's why we have a dot at 1. The reciprocal of -1 is also -1, so that's why those two dots appear on both graphs. Just like you did with your reciprocal functions, everywhere you had it equal to 1, you put a dot, and everywhere you had it equal to -1, you put a dot. Now at these points, the reciprocal of 0 is undefined, and so that's why they have these asymptotes. And you have an asymptote here. And then in between your asymptotes, you approach the asymptote, go through your dot, and then approach the asymptote again. Approach your asymptote, go through your dot, and approach your asymptote again. So you may find it helpful to pause the video real quick and draw this graph out so that you have what y equals cosecant looks like. So if you want to do that, you can. And then once you unpause the video, we'll go over the next one. So this next one, we put our dots everywhere it crosses at 1 and -1, and then everywhere it crosses the x-axis, we put our dots and we connect our dots. And so again, we're going to use Calc. The center line is 0 and the amplitude is 1. And since this curve is a cosine function, we're going to do the reciprocal of cosine, which is secant. And it starts at a max at the origin, so we don't have an angle change, and from here to here is 360, so we don't have a period change, so we just have secant of theta. If you have an angle change or a period change, then it works the same way that you did with the sine and cosine. It would just be on your secant equation instead of on a sine or a cosine. So again, if you want to draw that graph and have it in your notes as what secant looks like, you can. Okay, so we're going to look at the next example. We want to find the equations of these trig functions. So we're going to connect our dots. And that would be a sine. This would be a sine curve. And what is our helpful friend? We got kappa. So the center line is 0, so we don't have to write that. Our amplitude, we only went up to 0.5, so we have 0.5. The reciprocal of sine is cosecant. We have no angle change and we have no period. So this would be your equation there. For the next one, connect your dots. And you're going to have that this is a cosine curve. And so we use our kappa. Our center line here is a 10. Our amplitude, we went up to 10.5, so we went up 0.5. Reciprocal of cosine is secant. And again, we don't have an angle change or a phase shift. So it's just that for your equation. So that's how you deal with the graphs of secant and cosecant. You see whether it relates to sine or cosine, and then you go on from there. And the best way to see if it's sine or cosine is to draw in whether it's going to be a sine or a cosine curve. Now looking at the graph of tangent. This is the graph of tangent. Remember that tangent is undefined at 90 degrees and at 270. Think about your unit circle. Tangent at this point and this point were undefined, and that's why you have your asymptotes there. And same thing at negative 90 and negative 270. At 0, the tangent was 0, and it goes through the x-axis. And at 180, the tangent is also 0. So what I want you to do is to take a minute and graph that on your paper. And then once you finish, you can unpause the video and I'm going to show you the graph for cotangent. Okay, so this is the graph of cotangent. Now they do kind of look similar, except for they are flipped and they're shifted by 90 degrees. So if you notice, the asymptotes are not in the same place. For tangent, they're at 90 degrees. For cotangent, they're at 270. I mean, they're not at 90 and 270. They're at 180 and 360. Okay? You also have an asymptote here on the y-axis. I'm going to graph the cotangent on top of tangent because cotangent is the reciprocal of tangent. So when we graph reciprocals, we put a dot everywhere that it equals 1 and negative 1. And then everywhere it crosses the x-axis, we put an asymptote. Okay? And then also on these, we haven't had this before, but everywhere you have an asymptote, you actually have where it crosses the x-axis. Because the reciprocal, it was 1 over 0, which is undefined, but the reciprocal of that is 0. And so that's why everywhere you have an asymptote, you put a dot because it gives you a 0. And so you're going to go through your dots and you're going to always approach your asymptotes. And so if you look, now maybe that'll show you a little bit how they are related. But that's where you end up with the graph of cotangent. Okay? So again, you want to put both of those in your notes. Hopefully you now have 4 graphs, secant, cosecant, tangent, and cotangent. You're going to want to study them so that you understand the shapes of them, because they like to confuse you by giving you tangent and cotangent. So now we're going to actually sketch the graph of y equals -2 tangent of theta. So on these, this is our theta and this is our y-axis. And we're going to go by 90s. So we have 90, 180, 270, and 360. You don't have to go any more detailed than that on this one. So we have -90, -180, -270, and then -360. And now for tangent, our asymptotes occur at 90 degrees and at 270. And so then we put them at -90 and -270. And then it is a negative. So instead of tangent going up like this, it's going to go down because it gets flipped because it's a negative. And so it's going to go this direction. Okay, so you're going to fill in between your asymptotes. Okay, and then the -2, that 2 is your amplitude. So all that means is that instead of that being a -1 and a 1, it's now a -2 and a 2. And so that's basically the sketch of the graph of y equals -2 tangent of theta. Now, don't make your things do this. They should not be completely straight. You should have a curve. Now, if you notice, I've got 3 full curves and none of them are exactly alike. I'm not going to count off, if they aren't all the same. You just need to make sure that you do have it somewhat curved, not a straight line. Okay? So on your homework, you do get to omit 20 and 21. So make sure that you do your homework tonight so that we can go over any questions you have tomorrow.